So we have discussed about how to simplify the Boolean expressions in order to reduce the number of gates. So suppose you have an expression, say y equal to, where y is a function, suppose a bar b bar plus a bar b plus say a b bar. So what you'll do is you can combine these two to form, take a bar outside, b bar plus b plus ab bar, then you'll write it as a bar into b bar plus b is 1 plus ab bar, so that is a bar into 1 is a bar, sorry, so that is a bar plus ab bar. Okay, so here you have two NOT gates for a bar and b bar, because inputs are always a and b. In this case you have only two variables, so a and b are the inputs. So in order to get a bar you need a NOT gate, in order to get b bar you need another NOT gate. Then here a into b bar, so you need one AND gate, right? And here you have a plus, so you need one OR gate. Okay, so this is what you need after simplifying the Boolean expression. This is your Boolean expression, and you needed 1, 2, 3. This is a simple expression, and for that you need this many steps to get this particular equation, and you need this many gates. Now, in order to simplify, this is a simple expression. There can be quite complicated expressions with 4 variables or so. So as the number of variables increases, it will get more complicated to simplify the expressions using this particular method, using the laws which we studied. So, and it will take many steps, maybe pages of calculations in order to get the final simplified expression. So that is a tedious work, and you may go wrong in the middle. So for that you go for the Karnaugh map. So this is a method by which you can simplify the Boolean expression in a single step or 2 steps. You can you just need to know some rules, which will become quite easy for you as you practice. So we'll be learning about 2 variable, 3 variable and 4 variable Kmap. So Kmap or the Karnaugh map, it can be used in expressions, in Boolean expressions, which is in the form of sum of product or SOP, sum of product, or in the form of product of sum. POS. Okay. Now what is sum of product and what is product of sum? Sum of product means, suppose you have an expression, say y equal to AB plus BC plus AC, something like this. So these each terms, they are products. This is a product, this is a product, this is a product. That is AND. Okay, you are ANDing the variables. And these products you are summing. Summing means OR. Okay, product means and this is OR. So any expression in this form, that is, which is in the form of sum of products, that is called a SOP. And if you have an expression in the form of, say, a plus b into a bar plus b plus a plus b plus c, something like this. So here each term, sorry, this is a product, this each term is a sum, and these sums you are taking the product. So it is the product of sums, product of sums, and the other one is sum of products. So these are the two ways by which you can write a Boolean expression, and the method by which you simplify these expressions, SOP or POS, slightly different using Kmap. So first we'll learn about sum of product, and in sum of product, two variable Kmap. So suppose you have an expression, say the expression is normally in the form of function of a comma b equal to sigma m, suppose 0, 1, 2, something like this. Okay. So this is called as the canonical form representation. Canonical representation of SOP. So in this, if you see, there are quite a number of things which you can see in this. This gives function of a comma b. So a comma b means you have two variables. So the expression will contain only two variables, a and b. Then this sigma m notates that this is an SOP. This is in the form of a sum of product. And see that this m is small letter. Small m. Don't write capital M. Okay. And these numbers in bracket that I'll explain, these give the, that is, the small m notates it as minterms. Now what is a minterm? I'll tell you shortly. So it is actually function of AB equal to sum of minterms. Which minterms? 0, 1, 2. Okay. So we'll explain as to what the 0, 1, 2 is. So my question was sigma m 0, 1, 2, function of AB. So for that you have to draw a table like this. So it is A, B. So it was function of A comma B. This was function of A comma B. So this will be your MSB. Since this is a two variable Kmap, you have only 2 bits. So the leftmost one should be your MSB. So the MSB will come here. Then the other one there. Okay. So here you have only 2 variables. So A, B, you have a partition like that. So A can take only 2 values. Right? A can take only 2 values. One is 0 and the other is 1. And B can also take only 2 values, 0 or 1. Right? So this particular cell has a value A equal to 0 and B equal to 0. So 0, 0, read it like this, AB, because it's written like this, AB. So 0, 0, 0, 0 has a value of, we know that, 0. So that is the cell value. And 0, 1, 0, 1, read it like this only, don't read it the other way around. 0, 1 has a value 1, 1, 0 has a value 2, and 1, 1 has a value 3. So these are the cell values. So my question was function of AB equal to sigma m 0, 1, 2. Now what this indicates is sum of minterms of 0, 1, 2. So 0, 1, 2, when you write like this, when it's in the case of SOP, what you do is whatever cell values is written inside this, those values you will put as 1, 0, 1, 2. Okay. So what this actually means is 0. 0 means it is A is 0 and B is 0. A is 0 means it is taken as A bar. B is 0 means it is taken as B bar. And since this is a SOP, sum of product, each minterm is written as a product. Okay. So minterm means product. Minterm is always a product. Okay. Now, how do you write the minterm of each cell? A is 0. 0 means complement. 1 means don't complement. So, A0 means A bar, B0 means B bar, and it should be written as product in the case of SOP. How do you know this is SOP? Because it is written as sigma m, sum of minterm. Okay. Now, 1 is, that is this particular thing is A is 0 and B is 1. So, A is 0 means A bar and B is 1 means B, and it's again written as product. 2 is A is 1 and B is 0, so B bar. And 3 is A is 1 and B is 1. So these are the minterms. So simple. If you have a 0 for any variable, write the complement. If you don't have 0, if you have 1, write the that particular variable as such and write it as a product for each cell. So these are the minterms. Now for this particular question, this is the general thing. Now for this particular question, you have only 0, 1 and 2. You don't have 3. So what you will write is, actually if you want to write the Boolean expression for this particular question, the question would be function of AB equal to sum of minterms. Sum of minterms means sum of product. Now what are the products? 0, 0. That is A bar, B bar, first one, plus sum of product, sum, A bar B plus AB bar. So this is my actual question. This particular question I have been asked to solve using this particular representation. Both are the same. So this was the question which we dealt with previously, which we took 3-4 steps to complete, and we had 2 NOT gate, 1 AND gate and 1 OR gate finally to implement that particular equation. Okay, so same question only, I have represented it in another form. Okay, so here while you are using Kmap, you needn't write this. You needn't write this. I just wrote this because to know what is the connection between the Boolean expression and the Kmap. So if you are given like this or if you are given like this, you can just put it inside the Kmap. That is A bar B bar. If it's given A bar B bar, put a 1 there. A bar B, A bar B, put a 1 there. A B bar, A B bar, put a 1 there. Or you can write as A bar B bar, both are complement. So it is 0 0. So it is 0, 0 1. So that is 1, 1 0. That is 2. Okay. Given the Boolean expression, you can write the canonical form, or from the Boolean expression you can map it to the Kmap. Given the canonical form, you can map it to the Kmap, or from the canonical form you can write the Boolean expression. Anyways, you can write the other thing. Fine. So coming to the Kmap again. So this is same as the earlier example which we did. So here are some of the rules of Kmap, right? So I will just write this. So my first rule is, in an SOP, I'm talking about only SOPs till I finish 2 variable, 3 variable and 4 variable. So it is always sum of minterms. So first is, all ones should be mapped. Should be mapped or grouped. All ones should be grouped. All ones should be grouped. You can't leave any one without grouping. Now, second is, how do you group? You can group ones in groups of, that is, inside a group you can have 1, 2, 4, 8, etc. number of ones. Okay, that is, when you group, inside a group you can have so many number of ones. You can have a single one inside a group, you can have 2 ones inside a group, you can have 4 ones inside a group, you can have 8 ones inside a group. In short, the number of ones in a group should be represented in the form of 2 raised to n. Okay, so 2 raised to 0 is 1, 2 raised to 2, 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16, likewise. So if you are trying to group the ones, just see whether the number of ones inside the group can be represented as 2 raised to n. That is, can you group 3 ones in a group? No. Why? Because 3 cannot be represented as 2 raised to n. 4 you can, 2 you can, 3 you can't, 6 you can't, 8 you can, 7 you can't, likewise. Okay, so that is another one. And normally we'll be dealing with normal Kmap. Like for complex you have other rules. Normal simple Kmap solving, you group it vertically or horizontally, the ones. You can group it vertically or horizontally. Okay, so we'll start with the grouping and I'll explain more rules as we go. So here all the 3 ones should be grouped. You can group it horizontally or vertically. Then the number of ones inside a group should be represented as 2 raised to n. Now another rule is that So the easiest way to group here will be single groups. You're grouping it in single forms. Okay, so if you group it in single ones, the problem is for each group you will be writing a product. So if you group it singly as single ones, then here you will have 1, 2 and 3 terms. So that is equivalent to my first question. So again you can simplify it. So there is no meaning in grouping it singly when you can group it in groups of more than one once. So the next rule is maximum possible number of ones should be grouped. In a group. So inside a group, if you can group say 8 ones, then you should group 8 ones. You can't just group 4 ones. Okay. The maximum number of, according to the rules, of course. According to the rules, if you can group 4 ones, you should group 4 ones. But if it's possible to group 8 ones, then you should go for the 8, not the 4. Okay, so if you can group 2 ones together, then you should go for 2 ones and not single ones. So here again, you can group it single, but you can also group it in groups of 2. So these 2 ones I can group like this. Okay, instead of single ones, I can group it together. Now next one is, here you have this one. This one also should be grouped. So how do you group this? You can group it singly. Again, my fourth point is maximum possible number of ones should be grouped inside a group. So my next doubt will be, this particular one is already grouped. So can I group this one with this? Yes. You can group a particular one any number of times. That is, a particular one can be a part of any number of groups, but use it only if necessary. Okay, so in this case, this particular one is alone. Okay, so if I group it alone, then it will not be simplified as such. So it will be, the expression will be simplified further only if it is grouped with maximum number of ones. So it is better to group it with this one than keep it single. So don't use a particular one to group if it's not necessary. Just for the sake of grouping, don't do it. But if it's necessary, then group it. So this is my answer. So how do you write this? So for each group you have to write. So this particular group, how do you write? So function of AB. So how do you write? This particular group, you have to see what is common for all the ones inside a group. What is common for all the ones inside a group? Those terms you will be writing as product. Then you will put a plus sign and move on to the next group. So this is my first group, say. So in this group you have 2 ones, this one and this one. So if I see A, For this one, A is 0, and for this one, A is 1. So A is different for both the ones inside the same group. When it is different, just leave it as such. Just ignore it. Don't write. Whatever is common, only write. So for this one, B is 0. For this one, B is 0. So for both the ones, B is 0. So I'll write that, and B0 means it is B bar. Then I'll put a plus sign and move on to the next group. So for this particular group, both the ones, A is 0. So it is common. A0 is common to both the ones. So A0 means it is A bar. B is different for both the ones. So it is A bar. So here we can see that you have two NOT gates like in the earlier case and one OR gate. One AND gate has disappeared. Okay. So it's always easier to solve using a Kmap. You can get it in the most simplified form using a Kmap. If you are using Boolean expressions, you should know all the laws and many complicated laws in order to simplify it to the best possible way. Okay, so here we've removed, we have one less gate. So this is the most simplified form. So while writing a Kmap, you just need to put the ones, group it and write. That's it. In 2 steps, everything is over. So group it in such a way so that you just need to write the final answer. Okay. Don't write it in such a way that after writing again you have to simplify. That is wrong. Then the Kmap solving you won't get full marks. Okay. So that is using 2 variable. So suppose we have function of AB equal to sigma m 0 to 3 say. So you have to write all these. Okay, don't forget to write this AB 0 1. Don't forget to write these. Then the numbers also, because if you don't write the numbers you can mess it up. Okay, you may get it wrong. 0 2 3. So as per the earlier rule, you can maximum number of ones in a group, maximum number of ones in a group. So my answer will be this. What is common to both the ones? It is B bar. Then put a plus. What is common to both the ones? It is A. So this is my answer. As simple as that. So that is 2 variable Kmap. You can try out some questions. Something like this. You can try out the questions and find the answers. Now next we'll go for the 3 variable Kmap. Mostly 3 variable or 4 variable only we'll be using. So in 3-variable Kmap, the question will be something like function of A, B, C. Here A is the MSB, C is the LSB. Okay, leftmost one is the MSB. Don't mix it up. Equal to sigma M so in 3-variable Kmap, it will be A, then you will write both the next two bits there. Okay, so A can have only two values, so you'll divide this into 2, 0 and 1, and always write 0 first, don't write 1, 0. Then BC can have 4 values, BC 2 bits, so 2 raised to 2, 4 bits, 0, 0, 0, 1. Normally it is 0, 0, 0, 1, 1, 0, 1, 1, but in Kmap you'll write it as 1, 1, 1, 0. So don't mess that up also. Okay. So why we are writing like that is, say, if you have two ones here and you group it, between the adjacent cells, there should be only one variable change. What does that mean? If you take these two cells, here B is remaining same, C is changing. If you take these two cells, B is different but C is same. If you take these two, B is same, C is different. Now suppose if you had written like this, then if you take these two cells, then B and C is changing. So you can't have a common value because everything will be different. That's why we are writing it as 1, 1, 1, 0. So always write as 0, 0, 0, 1, 1, 1, 1, 0. Then write the cell values. 0, 0, 0 is 0. 0, 0, 1 is 1. 0, 1, 1 is 3. 0, 1, 0 is 2. So it is 0, 1, 3, 2. Then 1, 0, 0 is 4. 1, 0, 1 is 5. 1, 1, 1 is 7. And 1, 1, 0 is 6. So it is 4, 5, 7, 6. So this is your 3-variable Kmap. Rest of the rules is the same. So it is 0, 1, 4, 7. 0, just put 1 in whatever numbers are written. 0, 1, 4, 7. Right? And we'll go for the grouping. So here, this one, in order to group this one, you have to group it like this. In order to group this one, you don't have any other, you don't have a 1 here, so you can't group it like that. So you need this one to group. And for this 7, you don't have any adjacent ones. So you can't group it with any adjacent ones. So you can group it only as a single one. You don't have a 1 and 6 or 5 or 3. So you can't group it with an adjacent one. So you are grouping it alone. So what is the answer? So this one will be, these are different. Common is B0, C0. B0, C0. Then go for the other group with a plus sign. This 1, 1. So A is 0 for these two. So A0 means A bar. And then see what is B and what is C. B is 0, so that is common. C is different. So take only the common one. B is 0. So B bar plus, go to the next group. Here it is alone. So it has a value of A equal to 1 and B and C equal to 1 each. So this is how you group and write the answer. So you can't simplify it any further. This is the final answer. Right? Now, suppose my question was, suppose something like this. So my Kmap would be A, B, C. Zero 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 one 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 zero zero one. So this is 0 1 3 2 4 5 7 6. So it is 0 1 4 5 7. Okay. So in this, in order to group, here you can see that you have 4 ones. So if you can group 4 ones, go for 4 ones, don't settle for 2 ones. So you can group these 4 ones together, maximum number of ones in a group, that rule. And this one, instead of grouping it single, you can group it as a group of 2 and then write. So these 4 ones together, what is common for all the 4 ones? A is different for all the 4 ones and B is same for all the 4 ones. B is 0 for these 2 and B is 0 for these 2. C is different for this and this. Okay. So only B is same. So what is the answer? B is 0. That is B bar. Plus, go to the next group. So for these 2, A is 1 and if you see B, B is 0 here and B is 1 here. So B is different. C is 1 here and C is 1 here. So it is AC. So it is B bar plus AC. That's the answer. So let's do another one. Something like 0 2 4 6. So A B C 0 1 0 0 0 1 1 1 1 0. So this is 0 1 3 2 4 5 7 6. So 0 2 4 6. 0 2 4 6. So in this we can see that these 2 ones are vertically can be grouped. These 2 ones can also be grouped vertically. But there is another thing, that is, if you see these 2 cells, these 2 BC values, you can see that B is different for these 2 cells, but C is same. So there is something called as folding. That is, suppose this particular thing is a book. Okay, this book, and 0, 4 is in this side and 2, 6 is in this side. So you can fold the book in order to make this 0, 4 and 2, 6 as a single group. So you are folding it how? You are folding it like this. You are folding it like this to form a single group. So 4 ones in a single group, and the answer will be just like a quad. Just like a quad. Quad means 4 ones. So what is common for all these 4 ones? It is C0. So the answer will be C0 means C bar. Yes, if suppose you had only 0, 2. 0, 2 means here you don't have, here you don't have. So you can fold it like this. You can fold it like this. And you can write it as A is common, A bar, and what is B is different, C is same. So it is C bar, A bar, C bar. Okay. So that is the case of 3 variable Kmap. So you can try few examples in 3 variable Kmap.